Hello students, welcome. Previously, lesson 7, form 4, topic 6, we were dealing with the second part of detergents where we have done soapless detergents. So today we are going to proceed to lesson 8 and we are going to do polymers. Learners, remember when we are dealing with the organic chemistry 2 introduction, we said this chapter focuses on 4 main areas. Number 1, alkanol. Number 2, alkanoic acid. Number 3, detergents. Then number 4, we're having polymers. So what are polymers? We're saying polymers are large molecules made by linking many small molecules known as monomers. So next, what are monomers? And we're saying monomers are small units joined together to form a polymer. The next we are saying monomers may be of the same molecule. That means they can be identical monomers or of different compounds. The next, let's see the definition of polymerization. What is polymerization? We are saying polymerization is the process through which the monomers combine to form a long chain molecule known as polymer. So next we are saying the polymers may be man-made, that is synthetic polymers, or naturally occurring polymers. So next we are saying natural polymers, also called biopolymers, are made by living things. Next we are saying naturally occurring polymers include rubber, cellulose, wool, silk, protein, and starch. Those are examples of natural polymers. Then next we are having synthetic polymers, which are also called plastics. And we're saying the major raw materials for their manufacture are obtained from petroleum or from petroleum products. Then next, what are some examples of synthetic polymers? We are saying they include nylon, we're having terylene or dacron, and we're having polyethene, which is also known as polyethene. Next we are saying they are made using 2 methods, that is addition polymerization and condensation polymerization. So let's start part A, that's addition polymerization. And we are saying addition polymerization occurs when unsaturated molecules called monomers join to form long chain molecules known as polymers without the formation of any other product. In doing so, we are told monomers open and bond with each other. Next, we are going to see examples of polymers that are formed through addition polymerization. We are going to do 6. Number 1, we are going to do something called polyethene, which is also known as polyethene. Number 2, we are going to do something called polypropene, which is also known as polypropylene. Then number 3, we are going to do polychloroethene, which is also known as polyvinyl chloride, in other words PVC. Then number 4, we are going to do polytetrachloroethene, which is also known as Teflon. Number 5, we are going to do something called polyphenyl ethene, which is also known as polystyrene. Then number 6, lastly, we are going to do a polymer called polymethyl methacrylate, which is also known as Perspex. Each of those polymers will be explained below. So let's start with the first example of a polymer which is formed by addition polymerization, and that is polyethene, which is also known as polyethene. So when we are dealing with these polymers, we are supposed to know 3 things. Number 1, we are supposed to identify and draw the structure of the monomer. That's number 1. Number 2, we are supposed to write the equation for the formation of the polymer. Then lastly, number 3, we are supposed to write a general equation for the formation of the polymer. So we start first of all by identifying the monomer. So for you to know the monomer, you are supposed to first of all know the polymer. So the polymer is polyethene. So we remove the word poly. What remains will be the monomer. So we're having ethene there. When we remove poly, we remain with ethene. So how are we going to draw the structure of ethene? Remember, ethene is an alkene. So we have a double bond there. This is the structure for ethene plus another ethene. So through addition polymerization, what will happen is that the double bond breaks up and we are going to have single bonds. So how many carbon are we having initially? 4 carbon. So these are 1, 2, 3, 4. Then how many bonds that each carbon has? 4 bonds. You have to know that. Then how many hydrogen are we having initially? In this ethene we are having 4. 1, 2, 3, 4 plus another 4. We are going to have 8. So when we count here, 1, 2, 3, 4, 5, 6, 7, 8. So we have 2 more bonds here. These 2 more bonds we are supposed to close with the polymer. So what we have drawn here is now polyethene polymer, which is also known as polyethene. Okay, next let's proceed to the general structure. When we are drawing the general structure, we are supposed to first of all have the structure of the monomer. This is how we draw the monomer of ethene. Then we put bracket, we are going to write N there. N represents to the number of monomers. Like for example, if we are dealing with 50 monomers of ethene, when they join together, they are going to form a polymer called polyethene. So we are going to put 150 there in the side of N. Through addition polymerization, what will happen? The double bond breaks up. So each carbon is going to have 4 bonds. Then how many hydrogen are we having? 4. 1, 2, 3, 4. So 2 bonds are going to remain. So these 2 bonds we are going to close with the polymer. Then we are going to put N there, which was for the number of monomers. So example number 2. It's called polypropene, which is also known as polypropylene. Then to know the polymer, we remove poly. What we are going to remain here will be propene. So that will be the name of our monomer in this case. So how are we going to draw? We can draw in this way, the way we have here. Propene is also an example of alkene, a member of alkene. So it has 3 carbon atoms. Then we're having 6 carbon. 1, 2, 3, and we're having another 3 that has 6 carbon. So this is propene monomer. But as another propene monomer, through addition polymerization, what we are going to get will be polypropene polymer. How are we going to have this polymer? Now what we are supposed to know is that the double bond in these 2 propene, they are going to break up and we are going to have single bonds. So the way we see here, we're having 2 carbon, here 2 carbon. In total, we're going to have 4 carbon in this side. So here we are having CH3, so we have 1 hydrogen, that's the hydrogen, another hydrogen, that is it. We're having 1 hydrogen up there, that is it. Then CH3, we are going to put here 1 hydrogen, that hydrogen is there. This hydrogen, it is here. This hydrogen is up here, then this CH3, it is here like this. So that means the 2 bonds that remain in there, we are going to close with the polymer. So you can draw in another way, like what you're supposed to do is, you put the 3 carbon straight, there's no problem. But as another propene, then when you join, you are going to have a total of 6 carbon with 12 hydrogen. So you put 6 hydrogen up, then 6 hydrogen down. What you are going to have will be 12 hydrogen. You are going to close the 2 bonds that are remaining with the polymer. So let's proceed to the general structure for that polypropene. So we have to have our monomer, which was propene. We put bracket, and we're going to have N to represent the number of monomers. Through addition polymerization, what we are going to get here will be the polymer for polypropene. So next, let us proceed to example number 3. We're having polychloroethene, which is also known as polyvinyl chloride, PVC. So for us to first of all identify the monomer, we remove poly from the polymer. So what we are going to remain will be chloroethene. So that means we're having ethene as our parent name, then we're having chloro as our attachment. So this is how we draw the structure of the monomer, chloroethene. But as another chloroethene, through addition polymerization, what we are going to get will be polychloroethene. So how are we going to get this polymer? How many carbon do we have? First of all, 4. 1, 2, 3, 4. The double bond breaks up, we are going to have single bonds. So next we are having 2 hydrogen in the first carbon, those are the 2 hydrogen. Then the second carbon we are having 1 hydrogen with 1 chlorine, that's 1 hydrogen with one chlorine there. Then the third one, we're having two hydrogen. These are the two hydrogen. Then we're having one hydrogen with one chlorine, one hydrogen with one chlorine. Then we are remaining with two more bonds. We close it with the polymer. So what we are going to have there will be polychloroethene. What about the general structure? We're supposed to have, first of all, one monomer here. That's chloroethene, the way it's written here. Then we put bracket on the monomer and we write N to represent the number of monomers. Then through addition polymerization, what will happen is the double bond breaks up. Then we're having two more bonds. We put it in bracket for the polymer. Then we put the N here for the number of monomers. Like if you are talking about 150 of a chloroethene, we put 150. Then we are going to put 150 down there. So next, let's proceed to example number 4. We are having polyvinyl ethene, also known as polystyrene. So the monomer here is phenyl ethene. So how are we going to write? First of all, we are having ethene as our parent name. Then we're having an attachment which is phenyl. So when you're drawing phenyl, you can draw it like this in a ring, or you can write C6H5 as it is formula. So that's one monomer. When you add another phenyl ethene through addition polymerization, what we are going to get will be polyphenyl ethene, which is also known as polystyrene. So when you check here, we're having 2 carbon plus another 2 carbon. Total we're having 4 carbon like that. Then the way you have here, we are going to put it in the first carbon, then 2 hydrogen here we put in the second carbon. We're having 1 hydrogen with the final attachment, we put it in the third carbon, then 2 hydrogen in the last carbon. Then we are remaining with 2 more bonds. These 2 more bonds we are going to close it with the polymer. Then let's proceed to the general structure. We're supposed to pick either this structure to represent our monomer, that's phenylethene, or we take this because they're the same. When we have that one, we put bracket on the monomer, then we write N to represent the number of monomers. Then through addition polymerization, what will happen? The double bond breaks up to form single bond. Then we are going to put the way they are here. Then these 2 bonds we are going to close with the polymer. Then we put N down there for the number of monomers. So next, let's proceed to number 5, polymer number 5, that is polytetrafluoroethene, which is also known as Teflon. Then from the name or from the polymer, let's identify the monomer. So the monomer will be tetrafluoroethene. How do you draw? We're having ethene as our parent name. Then we're having 4 attachments which are on the same kind, that's fluoro. So we're having 4 fluorine, the way you see FF like that, plus another tetrafluoroethene. Through addition polymerization, what we are going to get will be polytetrafluoroethene. How are we going to do it? How many carbon do we have on the monomers? 4 carbon. 1, 2, 3, 4. So how many fluorine do we have here? We have 4 plus another 4. Those are 8. When you count 1, 2, 3, 4, 5, 6, 7, 8. Then we are going to have 2 more bonds to close with the polymer. Then let's proceed to the general structure for this polytetrafluoroethene. We are going to have, first of all, one monomer. The structure of one monomer, we are going to put bracket. We put N to represent the number of monomers. Through addition polymerization, the double bond breaks up. We are going to have single bond. Then these 2 bonds that are remaining, we are going to close with the polymer. We are going to put N there for the number of monomers. Next, let's proceed to the last polymer, which is polymethyl methacrylate, which is also known as Perspex. So here, the monomer will be methyl methacrylate. That will be our monomer. The way it is written or it's drawn, its structure is like this. So we add another again methyl methacrylate. What we are going to get will be polymethyl methacrylate. So what will happen? We are going to have 2 carbon with 2 carbon. Those are 4 carbon. The double bond breaks up. Then we have 2 hydrogen in the first carbon, the way you see here. In the second carbon, we have 1 hydrogen up there with the COOCH3, the way you see here. Then we're having 2 more hydrogen in the third carbon, the way you see there. Then we're having 1 hydrogen with the COOCH3, the way you see here. We are going to close those 2 remaining bonds with the polymer. Then the general structure. We pick 1. Then we put N to represent the number of monomers. Then through addition polymerization, the polymer will be looking like this. So how have we gotten this? We remove the double bond, we make it a single bond. Then we're having 2 hydrogen, the first carbon, the way you see here. Then 1 hydrogen, the way you see there. Then COO, CH3, the way you see here. Then we're remaining with 2 more bonds here. We are going to close it with the polymer. Then we put N here for the number of monomers. Learners, that's the end of our class for today. Thank you for watching.